Hello everyone. So the topic for today's discussion is conversion of context-free grammar to push-down automata. So to convert any given context-free grammar to the corresponding push-down automata that can accept it, here are the set of rules. So if this is the given set of rules for the context-free grammar G, the PDA would be obtained as this. So here V is the non-terminals, terminals, P is the production rules, and S is the starting state. Similarly, for PDA, we'll have set of states. However, when we do this conversion, we just have one state, say Q. Next, we have a set of alphabets. So how to find out the alphabets? Now, all the terminals of the context-free grammar will be the input symbols for the PDA. So this set of alphabet would be the terminals of the context-free grammar. Whereas all the non-terminals and terminals of the context-free grammar can be the stack symbols. Set of transitions. To find the set of transitions, we have these two rules. So the rule here says that, so since we have only one state, it is Q. So for all the rules of this form, or rather we say for all the non-terminals which are of this form, we will write the state. And since it is the same state, the transition would go to the same state. Then we write epsilon here. This A is the non-terminal under consideration. And this gives me Q alpha. Alpha here is the transition on the right hand side. Then for each terminal symbol A, this is the rule that needs to be written. So QAA will give me Q epsilon. So these two rules are to be followed when finding out the transitions. So let us look at an example. So here there are two non-terminals S and B, and since the PDA has only one state, so that state is Q. All the terminals, so which are 0 and 1, will be part of the input alphabets. All the terminals and non-terminals are the allowed symbols on the stack. Next, transitions we will be finding out. So to find out the transitions, we consider the first rule, S tends to 0 BB. So for this, S tends to 0 BB, the rule will be written as Q epsilon. The non-terminal under consideration is S. This gives me Q and alpha. So what is alpha? Whatever part is there on the right hand side is alpha. So this 0 BB is written here. So this comes from the rule 1 which we just saw. Next, we'll consider the next rule which is available. This is B tends to 0S. So there are three rules which we can expand to. So let us consider the first one, B tends to 0S. So this is Q epsilon. P is the non-terminal under consideration. This is Q. And next we have to write alpha. So this is my alpha, 0S. Now considering the next rule, which is 1S. So this is again B tends to 1S. So this non-terminal we have already considered here. So we can just have an OR and write down the remaining alpha. So this is Q. The current alpha is 1S. The next alpha is 0. So this is 1S and then this is 0. So these are the rules that we will get corresponding to the non-terminal rules which are available in the given grammar. However, for the terminals, so terminals we have 0 and 1. So for both these terminals, we'll have to write more rules according to the second rule which we saw in the previous slide. So this is Q 0 0 for this 0. This is Q epsilon. Next is Q with 1 1. It is Q epsilon. So these are the four rules that will be, or set of four production rules for the PDA that will be obtained by converting CFG or context-free grammar to this. Now let us see if this context-free grammar is able to accept correct string. So this is 0, 1, and then this is 4 times 0. It is 0, 1 followed by 4 times 0. So we check whether this string would be accepted by this PDA set of rules which we have written. So here is checking for the validity of this string. Here written in red color are the rules which we just wrote in the previous slide. And now let us one by one check. So this is the transition. We start with Q and this is the input string and the starting state is S. So when we do this transition, what happens? Q is getting 0 and this is S. So we will apply rule number 1 because Q is getting S and whatever may be here. So the transition says we have to transit to Q. This string is as it is, and instead of this S, it is expanded using the rule 0BB. So we have replaced this with S with 0BB. Now, this time Q gets 0 and we have 0 here. So Q 0 0, which is rule number 3, this says that you have to basically pop whatever is there. So what we do, this 0 is processed and this 0 is also processed. So from the stack, we have popped this 0 and input is already processed, so this is removed. So now what are we left with? We have 1 4 zeros followed and stack has BB. Now Q gets 1 and B on the stack. So if B is on the stack, we'll apply rule number 2. And since we need to get a 1 according to the input string, we will expand it using this 1s. So this B is replaced by 1s on the stack. Again, we have 1 and 1. So according to rule number 4, this will be popped from the stack and we have processed 1. So we have 4 zeros remaining with SB on the stack. Next time this 0 and S. So we will replace S by 0BB and this B is as it is. Again, we have 0 and 0. According to rule number 3, this will be removed from the stack and input is processed. So we'll be left with 3 zeros and 3 Bs on the stack. Again, 0 and B will be processed according to the second rule. And since we have 0, we'll expand it using a normal 0 this time. So it will be 0. We remove these two ahead. Next, again, we have 0B. Again, applying rule number 2, we will be removing this 0 0. Again, this is replaced by 0. So there is nothing on the input and the stack. So this is 0. Since it is empty stack now, it will be accepted. So this is how the context-free grammar was converted to PDA and we see that it accepts a valid string. Let us take up one more context-free grammar and try to obtain the corresponding push-down automaton. So here are the two rules that we had to use. So for non-terminals of A tends to alpha type, the rule that we have to write is Q epsilon. This is the non-terminal under consideration. We write Q. So whichever is the state here will be written here, comma alpha. So here we write whatever is there on the right hand side. So this is the first rule for non-terminals. And for all the terminals which are there, so say for terminal A, the rule will be written as QAA, transition of QAA. This gives me Q epsilon. So whatever is the state here will be same on the right hand side. So let us do it for the first production. S tends to this. So this will follow rule number 1. So accordingly, we'll write transition of say Q epsilon. The non-terminal is S. This will give, now since there are 3 production rules, we'll have 3 transitions. So first is Q and alpha is 0 S X. So this is the first transition. Or the next transition would be Q 1 S Y. The last transition will be Q epsilon. So this is the production in PDA corresponding to this S. Now let us do it for the next rule, extends to 1. So Q epsilon, the current non-terminal is X, get Q, comma, the alpha part here is. Next, doing it for Y tends to 0. So we have Q epsilon Y. This gives Q comma 0 because the alpha is 0. So these are the 3 transitions that will be generated corresponding to this first rule which we have seen for the non-terminals. Now let us see for the terminals. We have 2 terminals here, 1 and 0. So for 1 we'll write Q11, that gives Q comma epsilon. Similarly for 0, we will write Q00, that gives Q comma epsilon. So these are the final transitions and this is the PDA that will be generated. Thank you so much.